Hey everyone, in this video we'll be looking at solving systems of equations algebraically. So there's obviously a way to solve for systems of equations graphically, and we're really looking at where these equations will intersect, and that's called the point of intersection, and which is the solution to the system. The points of x and y will be the same on both of the lines. The issue when we're looking at graphing, however, is sometimes we cannot determine an accurate point of intersection because you're estimating where these two systems of equations will intersect. So algebraic methods are the best ways to find exact solutions for equations. And so the first way we're going to look at is what is called substitution. And so if we're provided with an equation here, we have y is equal to negative 2x minus 5. And we have y is equal to 3x plus 5. And so the first thing we want to do is we want to start by labeling the two equations as equation 1 and equation 2. So that would be the first step. So let's write that down. So first step is to start labeling the equations as equation 1 and equation 2. So that's what we'll do to start. And here, then we will isolate for a variable in either equation 1 or 2. So we will isolate for a variable in either equation 1 or equation 2. Generally, you just use the first one, so you isolate in the first equation, but it's not necessary. You always have to isolate for the variable in the first equation. You can do it for the second equation as well. So here we see that it's already isolated to be y is equal to negative 2x minus 5. So step 3, or the third step, is to sub the expression. So sub the expression in for that variable in for that variable in the other equation. So here, what we'll do is we'll sub equation 1 into equation 2. So sub 1 into 2. So here, everything that is equal to y will sub in for y. So here we would sub in negative 2x minus 5 is equal to 3x plus 5. And so now they're equal to each other. And so now we're going to solve for the unknown variable. So next step here is to solve for the unknown variable. And so here you should get a numerical value. Okay, so if we do this, we're solving algebraically. So we move everything that is x to one side. So we'll subtract this by 3x, subtract this by 3x. The constants all to one side, so we'll add by 5, add by 5. So here we would have negative 5x is equal to 10 divided by negative 5 to both sides. X is equal to negative 2. So once we sub that in and we get a numerical value of x is equal to -2, what we want to do is we want to sub that numerical value into equation 1 or 2. So step number 5 will be to sub the numerical value for the variable back into equation 1 or equation 2. And either or, whichever one you sub it back into, you should still get the same answer. And so here we have y is equal to -2 times -2, which is the x value we just found, minus 5. Here y is equal to -4 minus 5, which is equal. Here we have y is equal. So, sorry, +4. So -2 times -2 is +4 minus 5, which will give us a value of -1. So that's our y value. And here we see that now our point of intersection we can write will be at -2 and -1. So that's the first way to solve for a system of equations. The second way to solve for a system of equations is what is called elimination. So if we are provided with something like x minus 3y is equal to -2 and x plus 2y is equal to 8. So the first step is to choose which variable we would like to eliminate. So the first step is to choose which variable we want to eliminate. And make sure both equations have the same coefficient for that variable. Okay, so here we see that the x values, we're going to eliminate that here. That's what we're going to do. And we're going to subtract those two. So we're going to get rid of the x, and we see that the coefficient is 1, so that's good here. However, if it's not, so if the coefficients are not the same, not the same, we need to multiply all terms by a number so the variable will have the same coefficient. So multiply all terms by a number so that the coefficient will be the same for both equations. Okay, so in this example, that's not the case. So we don't need to do that. But again, if the coefficients are different, then you will have to then you'll have to change it so that the coefficients are the same. Then your second step is to then stack the two equations. And you can either add or subtract depending on what's happening. So stack the two equations and add or subtract in order to eliminate the variable. So a general note here is if the sign of the coefficient is the same, you're going to subtract. If the sign is different, then you're going to add. So same sign, subtract, opposite sign, add. So here we're going to subtract. And so x minus x will give us 0, or that'll cancel out. -3 minus 2y will give us -5y. -2 minus 8 will give us -10. And here, then you can just isolate for the variable in the remaining expression. So here we'll write isolate for the variable in the remaining expression. So here we know that -5y is equal to -10, and therefore y is equal to -10 divided by -5, which is 2. Then the last thing you want to do here is you want to sub the numerical value into either equation to find the value of the other variable. So here, we'll sub it back to equation 1. And so here we have x minus 3 times 2 is equal to -2. X minus 6 is equal to -2. X is equal to 4. Your last step here will just be state the POI, the point of intersection here, which will be 4 and